Hello, uh, hello everyone. Welcome to uh, this version of the Hack Atom workshop. My name is Dipanshu. I'm the CTO at Persistence, and Persistence works at one other SDK on top of what already exists with Cosmos. And in this particular workshop, we will be guiding you through how to enable DeFi use cases in your application with as minimal effort as possible for the hack atom entries. So, yep. Before we start off, before we kick off this workshop, I'll give you some time to get access to to this particular document on my left, which contains all the instructions relating to this particular workshop. So this is the link if you want to type manually, or you can also scan the QR code on the right side of the screen. So, yep, I'll give you guys time to scan or get access to this document. In the meanwhile, let me guide you through the breakdown of this particular workshop. To start off, as this particular workshop is regarding DeFi, so it will make sense. First, determine what should our application be capable of. What should our application allow for it to be called a DeFi application. So we'll get into the basic definition and the rule set that the application which the application might have to abide by in order to be termed as a DeFi application. Then we'll get into setup. I believe everyone on the call have got an opportunity to look at the setup document. If you're set up, that's great. If you're not, you can maybe pause this particular stream and get set up and then resume later on. So I'm not going to wait up for this setup part. I'm going to continue moving on. You guys can pause and set up this for this particular section. Then I'll get into the Cosmos SDK modules that you guys might uh, find the most useful while building your DeFi use cases. In general, there's no point to exclude any of the Cosmos SDK modules when you're building your application. But this particular section, I'll try to get into details about how these modules function, so that you have a better idea when you're utilizing, or if your application so requires to modify these modules. Second, we'll get into the Persistence SDK modules. There are four modules that you will require for building out NFT-based use cases. That's the key point here. That's the main point of contention of this particular workshop. That majority of the DeFi uses right now are around tokens. So you can do certain mathematics and certain methods on top of your tokens, which are basically numbers in your wallet, and produce your application. But for this particular workshop, we are also gonna diving into how can you include NFTs as one sort of token inside your function for your DeFi application. So not just tokens, not just fungible tokens. We are also going to be dealing with non-fungible tokens, which is going to make things a little more interesting. Then we are gonna go into how if you wanted to while building your application import the Persistence SDK module into the project. Then we'll go into uh, details about if you have imported the Persistence SDK module, how will you go about interact these modules, as in how you send transactions or receive query messages from these module. Then we'll get into the setup process for the asset mantle project. So basically, uh, the Cosmos, you have the Cosmos SDK and the Gaia application, which you can utilize to like build your application, adding more modules to it. Similarly, we have got Persistence. At Persistence, we have built out the asset management module. So this module contains the minimum click of modules that are required to run an end-to-end NFT use case, because an NFT-based application requires more than one module to run. For example, it requires a wallet, it requires identity, it requires metadata module on top of the basic NFT module. So Asset Manager is the most basic project one to run a full NFT-based end-to-end application. So you may look at this particular application to start off from, or you may directly start utilizing Gaia, whatever works best for your particular application. Then we'll do how would you go about defining your own. Given that you have imported these modules, how would you go about defining your own NFT structure? Would you issue, mutate, and transfer it? And then when the whole process is complete, the whole life cycle of NFT is complete, how would you go about burning it? So this particular does not employ any coding at all. So this particular part is, given that you have imported the modules, you can just send transactions to do all of this with your code. So that's a great part, because for your hackathon, if everyone might not have the time required to build out their whole NFT module themselves. So one can directly import and through the transactions be able to define their own NFT structures and like trade them around all of the functionalities around NFTs. And if you wanted other modules to interact with it, there are objects called auxiliaries, which are exposed by these modules, which we'll also discuss, as in how you can make other modules communicate with these asset-based modules. Then, if time permits, based on how much time we've got left, we will go into defining our own custom asset module. So, in a scenario that the asset module that the SDK persistent SDK import is not in alignment with the project that you want to build for Hackam, you might want to go ahead and define your own custom module, and we'll go into how would go ahead about defining such a module. Of course, there would have already been many workshops on how to define your own module. So for that particular to put a little twist to it, we're gonna be doing it the persistent way, the persistent SDK way. We are gonna be using the persistent SDK types and interfaces to define this module, which makes it a little quicker to define. And then finally, on top of the tools that we would have introduced throughout this workshop, we at the end will discuss other DeFi tools that present in the Cosmos ecosystem. For example, one might require an Oracle or a stablecoin minting through CDPs, or one might require a stablecoin directly, or let's say AMM, for example. One might require a bond curve based AMM. So all of these tool sets are available. They are already built out in the Cosmos ecosystem. I would just lightly touch on these and make the links available so that you guys are all aware that such modules exist, and one does not necessarily have to re-implement them, and be quicker with building for Hackathon hack entries. All right. So I assume that you guys would have by now gotten access and opened up this particular documents, and then close the QR code. And yep, let's get started with the basic definition. So yep, what does a basic DeFi application imply? What functionality at minimum should a DeFi application have? for it to be called application. So first of all, as the name would suggest, it's a decentralized financial application. So it's a financial application. It must enable one of these, but not exclusively these set of use cases. For example, they might enable credit markets, token derivative or synthetic asset issuance or exchange, asset management, or prediction market. So in this particular workshop, we are going to be discussing majorly focus on this particular actually token exchange also. Token exchange, synthetic asset issuance and exchange, and asset management. This is what we'll be concentrating. But as I said before, are not the only financial use cases. And this is not an exhaustive list. One can define more financial applications for DeFi. For example, one can think of insurance on chain or credit rating. These will also fall under the DeFi use case. Secondarily, the DeFi application must be permissionless, as in there should be no one central authority defining the parameters or defining the events and metrics on top of this application. So for that particular effect, either these parameters for your application might be dependent on external input parameters. For example, or it could be information coming out of the source, or it could be algorithmic. For example, in like AMMs, which depend on an algorithm to define change it. For example, you can have your own algorithm to define parameters in your application. Or thirdly, if both of these are not able to cover your parameter definition, then you have to go to governance, as in you'll have to define your governance tokens and the or governance metric for each individual that are participating in your application, for them to be able to propose and vote on a parameter change. So yes, one has to be cognizant of this particular point when building a DeFi application. Then, of course, we are in the crypto space, so it's expected that a DeFi application does not necessarily require a KYC, AML, or does not necessarily require you to reveal your identity, because all of the state of your application is publicly available. So A, that's one reason. B, it should not be necessary. Your algorithm system should be such that even without exposing someone's identity, the application is still able to function well and able to determine prevent any frauds from happening. Third is non-custodial. There should not be one single party that is custodizing an asset. So no one wallet should be taking ownership. No one key should be taking ownership of any of the custodized asset. It should be custodized by the code, by your algorithm, by your application, and not dependent. Again, this is a corollary of the second point, which is permissionlessness. And decentralized governance is again like one individual or group of individual. Any individual with a veto power should not exist in your system. It should be dependent on a governance token and be determined by a set of members in the governance system. Again, this is a corollary of the permissionless point. That so yep, non-custodial, decentralized government, and permissionlessness. These three could be grouped into one category, and at the same time, these three together become the most difficult problem to solve when you're building a DeFi application. So yeah, let's go ahead and see how can we solve these problems. Now we have the setup part. I'm going to assume that you guys have already set up. So I'm going to skip over it. You guys, if you have not set up, or if you do not want to set up, that's fine. You can pause this video right now in future and do the setup and then follow along later on. Yep. getting into the next topic, which are the Cosmos SDK module that you must be aware of when you are building your application. So there are a bunch of modules that already exist in Cosmos SDK. For example, let's go and check out the modules that Cosmos SDK gives us. So for this workshop, we are going to be using Cosmos SDK version 39 because it's the LTS version. Like, never mind this particular screen. Like, this is how your Go mod should look like when you're importing. Yeah. So in your Go mod, you must import Cosmos version 39 for this workshop, or when you're building an application which is borrowing for this workshop, because that's the assumption that we are working under. All the code, etc., is in sync with how code should look like in version 39. We have recently, Cosmos SSD has recently been updated to version 4.40, and that enables that's a Stargate codename Stargate update, and that enables like majorly two gate features, which is the amino codec has been replaced with protobuf, Google protobuf uh, codec, and secondarily we now have version 1 of RC also. You may be able to build out layers and pipelines that allow interchain communication. So yeah, if you're building a project that is using version 40, then in that scenario, the code that is being discussed on this particular workshop might not directly apply to you. You might have to still make some changes for it to work with your project. So with that disclaimer out of the way, let's get into the modules that Cosmos SDK makes available to us for building application. So we have got these modules under the X package. We've got auth bank crisis distribution events, gen accounts, government mock, so on and so forth. Still upgrade. But one necessarily does not need to know about all of these. So I'm just going to touch up on the main important ones. So those are the bank, auth, and param module. So basically, the bank and auth modules together enable you to maintain a wallet, enable you to send and receive tokens from your wallet to your wallet, and also enable stuff like giving permissions through your key for sending or receiving, signing transactions, creating transactions, and sending them, etc. The params module is the one that holds all the parameters for the other modules that through governance proposal can be modified. So this is important because if you have parameters in your module that need to be that are supposed to be modified by governance and are not hard coded or centrally determined, then one also has to utilize params module directly inside their module. So yes, these are the three modules that I'm aware of. Not wasting too much time on this. Mostly one can directly import these modules as is and utilize them. But in scenario that you do want to modify them, I guess it's your prerogative to do so, and it's easy enough also to be able to do that. But in majority of the scenarios, I would recommend a direct import works best because it's a tried and tested module that have been deployed in production. No, 39 has not been deployed in production, but yes, it's a tried and tested module. So one might as well depend on these modules being directly imported inside your project rather than you modifying them. So modules from Persistence SDK that you might want to utilize in your project is identities. So although we are on version 39, in the workshop is on version 39, these modules are built out to be ready for the interchain world where one might be able to send assets across chains. So for that scenario, the identity module enables one singular wallet. Identity does not mean a KYC identity. It could be a simple identity like a username also, or it could be a more complexly defined identity by an issuer. For example, it could be a DMV motoring license, or it could be your national identity. It depends on who is issuing this ID. They can make it as complex and as simple as possible. So what this identity allows you to do is have a singular identity and have your identity be linked to this particular identity, real identity, your wallet be linked to an identity rather than a private key, rather than an address. So, like an address, you might tend to use a private key, you might tend to lose. But when we are dealing with like real scenarios, for example, let's say you have tokenized your car and now it's in your wallet, and you go and if you go on and lose your keys, then that makes it impossible for you to be ever able to transfer this car to for example. So to like mitigate such problems, this identity module, it enables you to add, or as we call it, provision more private keys to your wallet and other unprovisioned keys from your wallet. So, for example, if you lose your key, then you might want to unprovision so that a malicious actor is not able to utilize your wallet. So basically, what this allows is if for you also to never expose your seed or write your seed down ever. What you can do is per device you can log in with your identity and create a new private key in situ on your device, maybe on a secure enclave, like the iPhone or Samsungs nowadays have pre-built inside them, or HSM or a ledger module, and uh, then never back up your seed at all. And if you lose your device, then you just unprovision that key, making the whole process a little more. Then we have the assets module. Assets module is the one that manages the NFTs as we call it, inter NFTs. Uh, so these NFTs can be sidechain while the ownership or the maintainership remains on the issuer chain. So this asset module is the issuer of the overall internet NFT functionality, which enables the issuer chain to be able to modify the NFTs in when that's required. The split modules is it maintains the splits or fractional ownership value of the assets. So it's kind of like a wallet. It's exactly like a wallet that retains your asset ID, your assets DID, and the number of or the fraction of the asset that we need. So for example, if it's a singular NFT, then we assign it the smallest decimal number, so that it could not be split together further. If it's for example uh, a share of organization, for example, or IPO entity, for example, then one might represent it as like real numbers as big as like upper bound of decimal, and each wallet's total uh, holding being represented as the decimal number and in the splits module. So the split module allows you to send and receive the transactions, send and receive your NFTs across chain. For the orders module is basically if you do not want to directly send your assets to and fro between wallets, but rather want to publicly auction or sell your assets, then these order modules allow you to have. Right now, at this particular stage, only allows you to have maker-taker based exchanges. In future, it will allow for more complex exchanges, for example, uh, uh, auctions or bids or AMMs. So yeah, right now it's just maker-taker based, COBD, central order book based exchange. So yeah, let's get into how do we go about importing persistence decay module into your project. So let's look at, I've created a base implementation of an application. Let's look at that application. So yep, in general, your application structure, the application struct might look something like this. If you're creating your application from scratch. So like it implement base app, it must, all of these other members are optional. It depends on your application specifically, but yes, this is the base implementation. So let's see how do we go about adding one module to your application. So yep. So first of all, whatever application you're creating, it could be Gaia or it could be Asset Mantle. You first have to add the dependency, persistent SDK dependency into your Go mod. Then the next step after that would be, in your application, you will have to add the key for your KB store, the key for the module's KB store. So for example, let's look at assets module. So yeah, this is how we define the set of keys for your applications KB store that needs to be mounted in future, that will mount later on. And one needs to add the keys, one needs to add the module keys inside here. So for the persistence SDK module, the module themselves define their store keys. So one has to add their keys like so. Then we need to initialize the module. So the initialization will look something like this. So for the asset module, you first give it the param subspace. What's a param subspace? So the parameter module keeper creates new subspaces for your module that you can store your module's parameters inside, which the params module also has access to and can modify through governance. So one has to add the subspace param subspace, and then add other auxiliaries or other dependencies from other modules. For example, if the splits module depends on the supply keeper to wrap and unwrap tokens, so one has to pass it like so. The input is Varadic interface. So in general, for persistence SDK, the past dependency would be in the form of a object called auxiliary. But if one needs to import Cosmos SDK based modules, then one can also pass the specific exact keeper structure like so. Then let's get into we need to add the message encoder to WASM keeper interface. So the WASM module is able to interact with your module through messages that it sends back and forth. But the WASM module also must know how to encode and understand your messages. So like all the persistence SDK module are compatible with the with COSM WASM. So and they have their own message decoders. If one wants to enable the interaction between your modules and COSM WASM, then one has to add the message decoder. So in this scenario, we added the module object which implements the method required for it to be message decoder, custom encoder for WASM. Then we need to add our module to app module, the applications module manager. So yeah, here as we saw in the structure above, the application structure, we have a module manager defined here. This module manager basically takes care of initialization of all your modules, extra initializations, and putting into place the endpoints, hosting the endpoints, etc. So yeah, we need to add our module here. So again, the module object exposed by the assets package, it implements the module manager interface. So you can directly pass the module object here, and it will get added to the assets module through the manager method. Then we can head and set the Genesis order. Genesis order is totally dependent on your application, as in which module is dependent on which. So one has to be careful about this and then set the Genesis order. And I think that's it. That's it. No, yeah. One has, if you want, you can also all the modules at Persistent SDK also define a simulator, which enables the simulation scenario where all the parameters could be randomly varied between a range, so that the simulator can test the module running in various parameter conditions and see if those situations would not lead the application to failure. So again, if you need to add the module formulation, add the module object exposed by the assets package. Here, assets, or it could be any of these modules also. One can just pass this object. This object implement the simulator interface. So this object should be able to add your module to the simulator. So yes, that's it. That's how one can add Persistent SDK modules to their application. There's no special coding required here, as is no special thought process required here. We just have to follow these steps that I just mentioned, and that's it. That allows you that your application will start having the module, will have added the module on top of its current set of modules. One thing to be careful about, all of these modules, when we are initializing these modules, some of the modules depend on other modules. For example, the assets module here depends on the classification, identities, maintainers, metas, and splits module. So one will have to also add these modules when adding the assets module. So other than that, we can just blindly follow this guide, and your game, when you run it up, if nothing goes wrong, we'll start expressing the endpoints exposed by these modules. So that brings us to the next component, which is how to interact with these modules once you have added these modules to your application. So it's very easy. Application, you just need to type in your binaries name, usually name. Either, depending on if you want to interact with a transaction or a query, just type in transaction tx or query, and then the name of the module, and then the name of the transaction or query. So for example, if you're not aware, if you do not know about, you're not sure about where would your what endpoints are exposed, one can directly utilize the CLI and get to know about all the transactions and queries exposed by a module, and also be able to see the input parameters that these transactions or queries would require. So in our scenario, if you look at the bottom right corner of the screen, you would see that I'm typing now. If the in our scenario, the name mainly is asset client because the project is asset management. So the asset, if you type in asset client, it will give you a set of all available. You can see we have TX and query here. So, for example, if you wanted to check what are the modules available, or if you wanted this is a good indication of if the module has been added to your application or not. So, yeah, if you look here, we can see that the asset module is added to our application. So we can run all the assets module applications. So asset modules transaction. So let's see what our transactions do asset model expose. So available commands are burn, define, mint, and mutate. So we will be looking into all these transactions, but yes, this is basically how you would interact, how you would get to know if a module has been added to your application or not. Similarly, if you wanted to interact with your application through the REST endpoint, you can follow this particular format, which is a HTTP, your host name, your port. If it's a persistent module, the path will be XPRT, then the module name, and then query or transaction. And depending on what is the method, it could be get or post. You'll have to vary how your transaction, how would you go about forming your request. So if one wanted to look at how a request could be formed, in the asset mantle project, there is a package, not a package, I guess directory, we'll call it directory in this scenario. There's a directory called .rest. So .rest has it defines all the endpoints that are exposed by the asset mantle project. So this is how it would look like. So one can take reference of this particular if one wants to send transactions through the points. Yeah. So this is how you interact with your module if you have imported it inside your application. But in certain scenarios, you wish to like directly start with the sum total of all modules exposed by the SDK, persistent SDK for NFT, inter NFT use case. So in that scenario, you can directly check out the asset mantle project, and it will have all the modules etc. configured. So one does not need to worry about importing the modules. They can directly run this asset mantle application. So how would one go about to do that? It's very easy. Just check the code base. Check out the code base through like this particular command, and it would lead you to something like this. Yes, we are already in the next, as you can see. Yeah, so we are in the asset mantle directory. If you're in the asset mantle directory and your Go is properly defined and configured, in that scenario, there is a script here which is called the setup.fh script. So it takes care of like getting rid of all the old state that you might have. Be careful about this. If you don't
Hey, we lost the audio.
the setup asset script, some of the inputs have already been provided. For example, the chain IDs, call test, etc. One can go ahead and modify it, but the simplest way to run it is the easiest way to set up your chain, and that's just to run the script, the setup.sh script, and yeah. So yeah, as one can see, like we would have uh, build the application, define the Genesis state, and yeah, this is the Genesis transaction, which is written out to your uh, dot asset node directory. It can change depending on what transaction you're running. So this is how you set up the project, and then you can directly go ahead and utilize the startup script to start your chain and the rest endpoint. So what does the startup script do? It sends the start command and the start rest server command. That's it, easy as that. So yeah, looks like our node and REST client have started. It also, so if one wants to look at the logs produced by the node, for example, one just needs to copy paste this command, and yeah, as you can see, our node is up and it's at block height 6. Easy as that. So yeah, very simple setup process. I hope it saves you some time for the hackathon. So yeah, these processes are running in daemon mode. Your exit signal is not terminate signal is not going to terminate these processes. So in that scenario, you will have to, if you want to end these processes, then you'll have to run the shutdown script, which is as running. Well, yeah, this is the script. So yeah, very easy, very straightforward. Like we'll save you guys a bunch of time. Yeah. So next, let's get into defining our own NFT structure: issue, mutate, transfer, and burn. So for this particular part of the uh, workshop, I'm going to depend on the asset mantle project itself, but it's not necessary that you utilize the asset mantle project for this particular steps. You just need the assets module and all the dependency that the asset modules require. As long as you have imported these modules into your application, you should be able to follow the same and be able to define your own NFT with requiring zero code, no code required for defining your own NFT structure. So getting into defining the structure. Yep, let's set up a new chain. Let's create new Genesis. So yeah, I'm gonna use the script for that, and I can start up the node directly from the command line right now, but I'm not gonna be doing that because need to follow up on the code execution. So I'm gonna be using Goland's debugger. Again, not necessary for you to utilize, and you can utilize any of your favorite IDEs. But for me, I happen to enjoy Golang, putting on Golang a little more. So yeah. Let's go ahead and start this. So again, all these configurations that I'm using here are present in the asset mantle project. So .run folder has all these run configuration that I'm going to be using here. So yeah, here are the run configurations. The start run configuration. If you check out the project and you are using Golang, then you should directly be able to replicate what I'm doing right now. So yeah, let's start the node in debug mode so that we are able to like put on and follow through execution. Yeah, node has So the first order of business will be to create an identity for ourselves. So for this scenario, like why, as I was explaining earlier, why do we require an identity? So this particular the use cases or the thought process behind having an identity is that every individual, as in a DeFi application, does not necessarily require, should not necessarily be required to expose their identity or do a KYC angle. So you might ask me, Panch, why would you like ask us to create an identity if DeFi application does not require to identify yourself? To tell, uh, your real life identity, that is the identifier that every human being or you have in the real world. But for me to be able to identify you on a environment, on a DApp environment, without having to refer to your real world identity, I have to create certain blockchain or DApp identity. So imagine it like that. This particular identity is not your real world identity, but rather an identity that you're creating for yourself for the DApp world. In general, the identifier used by other DApps is your the public key or the address of your private key that you generate. But in our scenario, we cannot depend on a private key to identify ourselves, because in you might your key, your seed or passphrase to your private key. In that scenario, if it's a real world use case, then you're losing your assets. So here we define an identity and then link the private keys to that identity, allowing you to have multiple private keys into your identity, so that in case even if you end up losing a few keys, you still have some format of key, at least one key left over in your identity wallet, so that you do not totally get locked out of your own ownership of assets. So yeah, to go about and create a new identity, I'm going to be utilizing an identity. So Nub Persistent, the identities module gets a very simple format of identity called Nub identity, which, as Nate suggests, it's like the first interaction point or the first way to start utilizing identities. So Nub identity basically like a username. It's actually a username. So a Nub identity only takes your takes string, that is your username, and if no one else has that username, then you get issued that identity, and you can utilize it across chain, across the interchain DApp world, to identify yourself, to add keys of any sort, and be able to maintain ownership of your assets. So yep, going ahead and issuing myself a Nub identity. So how your issuance process look like? If you're using the CLI, you first have to specify client finding name, then TX for transaction identities. Nub is what defines identity. Minus Y is to skip a confirmation. Minus chain ID is you have to specify the chain ID that you are going to be sending this transaction. From is the key, the that you would have generated, that you're sending this transaction from, and Nub ID is the username that you want to pick for yourself. So in this case, I'm going to be utilizing this username, this string as my username, and yes, let's see if this identity is available. So I'm going to go to identities and check query all identities if there are any identities already defined for my new chain. So yeah, as I can see, there are no identities at all. So yeah, let me go ahead and create a Nub identity. The content, the transaction that I'm sending is exactly what's on the left, no difference with that. So yeah, I can see that the transaction has gone through. Now let's see what the execution process looks like here. So yeah, we are in the transact method of the nub transaction. So I've already like set up this debug for all the transactions also. So yeah, let's go ahead and see what's happening here. So first, this my message would look something like this. My message has just two parameters, which is my from address and the nub ID, which is the username that I've given. And this message then lands up in my keeper method. So first of all, I'm gonna be using the scrub auxiliary, which is gonna be sending a new request to the meta module, and it's going to be checking if there is any metadata that's already exists that has the username already defined. So if there's no error, then that implies that it has been defined before. Then I'm going to be getting the immutables. In our scenario, there is only one immutable, which is my nub ID, which is my username. So the immutable here, as we can see, now it has been hashed like through and through this project. No the strings are stored on chain. All the strings are hashed and stored. But in scenario you want the metadata to be exposed, the metas module will enable you to reveal the metadata behind a hash. So in our scenario, as you can see, I have gone ahead and for the immutable properties, I'm uh, just having a hash instead of the username, so that if I wanted to keep my username a secret, I can do that and only verify if the username belongs to me through a transaction or something. So then if the classification does not exist, since we're running it for the first time, it's going to go ahead and create a classification. It's going to create an identity ID, which is basically hash ID plus the hash ID plus the classification ID. And then I'm going to be issued I'm going to go ahead, go to the mapper and create a new collection, which is basically the entity manager. So it takes the mapper and context to create the entity manager, and I'm going to go fetch the entity that I've just created. If the identity already exists in the keyword, then I'm going to be getting then I'm not going to be getting an this object would be not nil. So which will basically mean that the identity already exists, and I'm going to throw an entity already exists. So yeah, as you can see, that we got back. Since all the checks have gone through well, I'm gonna go to my entity manager identities object here, and I'm just gonna add the new identity. So this is how my new identity looks like. Yep. So what does an identity have? It's have the identifier of the identity, and then it has a bunch of addresses, which are the provisioned address. So here the from address is the provisioned address that is currently linked with the identity. Then we have the deleted addresses, which is none. So these permanently go out of the list of address that you can add for identity. And we have the immutable properties. In the area, the immutable property is just the username, and then we have the immutable property, which this being self-sovereign identity, the owner of the identity can mutate these. So in this scenario for nub identity, there are no mutable properties. What is possible is for a person to define more complex format of identity and then be mutable properties. So as I was discussing before, one can create complex identities like driver's license. So in a driver's license, your name or date of birth or parents' name might become immutables that you can save as immutables, and your address and mobile number could be stored in immutable. So you may in future choose to change these properties. So this is how you create an identity, and this is how you link an address with your identity. So on top, what I can also do is I can provoke key to my identity or unprovision a key or delete a key from my identity. So if I am sending, if I need to send a transactions for this particular identity, I can use any of the provision keys. So yeah, that's how you create an identity. Let's pass on and complete execution. So yeah, this is the hash ID that I received. Now I can take the hash ID if the transaction has been done, or I can directly go and query all identity and say if an identity has been added there, because right now there were no identities, so should be able to check. So yeah, as I can see, I have gotten an identity added whose classification is this, whose hash is this, and the provision address list is this, no unprovisioned or deleted addresses right now, whose identifier is this, which is hashed, and whose no mutable properties, only immutable properties. So for our nub identity, the username was is something that I want to expose. So I set it as a meta. So it should be exposed on chain right now. So if I go and query all the metadata that have been ever exposed, I'd see that, yeah, that my username has been exposed as in by the metas or metadata module. So yeah, that's how you define an identity. We have also queried the identity. Now I'm going to be defining the structure of my NFT. So yeah, let's look at the transaction structure. What does the transaction contain? How would you go ahead and go about like structuring your NFT? So as we can see, TX assets define. The assets is the module name, define is the transaction name, chain ID is your chain ID, from is the key that you're sending the transaction from. The from ID is the ID that you created. So this is the ID. This is my ID that got created. So any address, any ID is able to define its own NFT structure. So anyone, it's which makes it decentralized, as in there's no singular authority, there is no centrality which is able to make new identities. It's rather any address that has the capability that wants to define the asset can go ahead and define the structure of an asset. So then for how would your asset look like? So your assets could have a bunch of properties. These are the broad classification properties. These are the 4 types of properties that you can assign your asset to, your asset could have. So they could either be immutable, as in once you issue the asset, they will never be mutated by any address ever, or they can be immutables, as in these that are transient and can keep on changing. So you can clump them and send them together like this. So how would your property look like? So first of all, the trade name of the thing, for example, if it's an address, we'll send address here. Semicolon is a separator between the name and the value. The value has got the value is separated by type. The value, the metadata types right now supported are string, are decimal, height, or ID. So string is represented by S, decimal by D, height by H, and ID by I. And pipe the value. So if you specify a value here, you can leave it empty, but if you do specify a value here, then all the assets that are issued by default will have these values. So for example, you are gonna say on ID that it's a DMV motoring license. So you can say type, and you can put in default value saying DMV motoring license. But a note here, if you do specify a default value for an NFT and it's an immutable, you will never be able to modify it. As soon as you issue an identity, it will have that immutable property, default immutable property, and you will never be able to modify it. So be careful about that. So you have yes. So your property can also be meta or non-meta. So a meta property is a property whose metadata is stored on chain. So like if you send a property as a meta property, then the metadata would be stored on chain, else only the hash would be stored. So yeah, these are the two types of immutable properties, immutable traits that you can assign to your NFT. And then we have the mutable properties. So mutable also have meta, as in properties whose metadata will be stored on chain. And then we have the non-meta properties whose property will never be stored on chain. So it's up to you if you want to like have the property be a meta or non-meta. So for this particular example, I'm gonna be having 4 properties, one of each name. I'm gonna name it A, B, C, and D, and I'm gonna have all of them as S or strings and with default value nothing. So let me go ahead and create this asset of this particular structure. So for your scenario, you can have a very different kind of structure. You can define properties like address, mobile number, URI, JSON of your object. It could be anything. It could be any structure that you would want your NFT, any information that you want your NFT to hold. So yeah, let's go ahead and define. Yeah, first of all, let me go ahead and see if any NFTs already exist. And so this is a new chain, I should have none. So yeah, I have assets and all the like definition of, let's see if there are any classifications of NFT that already exist, if someone has previously defined an NFT or not. So here I can see that there is already one classification which pertains to the identity that I just defined. So it's a nub identities classifier. So this particular entity represents the classification, which is nub identities. So no other types of classification that exist right now. So let me go ahead and create a new classification, which is assets of kind mine kind that I'm just gonna define. So let me go ahead and define now this transaction. So yep, look like the transaction ran. Let's go through the execution process. So here is what my message looks like. From address, the from ID, immutable traits. What the immutable trait I have right now is ID. In fact, is A. The property A, whose fact A, and signature. The signature I'll get into later. One can also sign properties for an asset. Then, yeah, I have the immutable traits. Mutable traits, all the traits that I sent. Quickly look at one more. So the field C has value nothing, default value nothing, as we just defined. Field C, default value nothing. But moving on, then I go ahead. Then I go ahead and to the verify auxiliary from which verifies if the from address belongs to the ID or not. The private key belongs to the ID that is being sent or not. So I take my from address, I take my from ID and check if the address belongs to the ID or not, as in the key that the transaction is being signed with is belonging to the ID that the transaction is being sent with. So it looks like there are no errors. So we can moving on. Then I go to my scrub auxiliaries. So scrub removes all the meta properties that are not supposed to be stored on chain and converts them to hashes. If there are meta properties, then it store metadata KB store. So I've scrubbed my properties. This is the immutable properties. Then we have the immutable properties. All of them are now scrubbed and stored. Now I need my classification ID. The classification ID takes in all the immutable properties based on the default values and the field name. It generates a classification ID. So as I can see, the new classification that I'm going to create, a new asset class that I'm going to create, will have this particular ID from now on. So the test represents the chain ID. So every chain can have its own definition of asset classes. And the second part is the hash of the properties. So yeah, now going to the super auxiliary. So the super auxiliary goes ahead and checks if the classification exists already or not. So it checks and it does not exist. And now I'm just going to create the particular ID classification. So yeah, letting it run on to my classification module and querying all the classification that have been created. So if the transaction has gone through, then I should be one more asset class, one more variety of asset. So yeah, looks like it has been created. This is the classification. This is the chain ID. This is the hash ID. As I was just mentioning, these are the properties. The immutable traits have a field called A with the default value here. B has no default value. C is of mutable property. It has no default value. It is of type string. And D has no default value of type string and mutable. So yeah, this is my property. Now this is the nub classification that we defined for nub transaction. So looks like our asset type has been defined. Now we must go ahead and instantiate and issue these assets to someone. So how would a transaction look like for this? The transaction for this would have a the from key, which is for locally we have a name anything for in this and called test. They called test. From ID is the ID that we just generated through nub. To ID is the person that we want to issue to. For this example, I'm going to issue it to myself so that I don't have to go ahead and create one identity. Classification is the classification just got created. So if you look here, see, this is classification. So test dot 2t141 test dot 2t141 is the classification ID, and I send my properties again now. So field A will be defined by A, B by string B, C by string C, D by string D. So let me go ahead and issue this to myself. So I'm going to run the min transaction, which is this transaction, assets min transaction, and see how the execution goes like. Yep, so we are on the min transaction. The message that I've received looks like this. It has a from address, which is of length 20, and yeah, can't decipher what it looks like. From ID, which is my from ID that I just generated from the nub transaction. To ID is my own ID. Then I have the classification ID. This is the classification ID that we just defined, the asset class. Property, the property that is just in the transaction field A, data A. So since my asset class already has a default value assigned to this particular, I not send anything other than A. If I try to send any other than A, the transaction is going to fail because it's an immutable property and it has got a default. So I've got to respect the default and send the default in the transaction also. So, but if you remember, we did not define any defaults for B. So I can set any value right now. So for this scenario, I'm setting small b as a value which has been hashed to this, and it's represented by string s. Similarly, this property C and D are present here. So yeah, first of all, I'm gonna verify if the key belongs to the ID or not. Then I'm gonna scrub metadata off of these properties so that no metadata which is not supposed to be on chain ends up on chain. Then I define my asset ID. Asset ID is defined by classification and immutables. Immutables have what we call hash. So both of them together create my asset ID. Then I create a collection. I instantiate entity manager for assets. So mapper asset takes in the current context and mapper object from the keeper to create and if I apply the fetch method, it will go to the Kiwi store and pick up the asset which has the asset ID as sent in the message. So I get the set of assets. If this assets is empty, okay, if this asset is empty, uh, if this asset ID is not found, in that scenario, I can safely say that the asset does not exist and I can go ahead and create. Else, I'm gonna throw an error. Entity already exists. So yeah, looks like the asset does not exist. So I'm good to go to create the assets. Next, I'm gonna be scrubbing. I'm gonna be scrubbing the mutable properties. So mutable property set scrubbed. Now I have good mutable property. Then I'm gonna go to conform auxiliary. So the conform auxiliary takes the classification ID, mutables and immutable properties, and checks if classification of the asset that I'm trying to issue and the properties that I've sent are in sync with each other. As in, if I'm trying to add any new field or remove a field that should exist, so it conforms to my asset checks and conforms that the asset I'm trying to issue conforms to the asset class or not. So it looks like it conforms to it. Then I'm gonna run the mint auxiliary. What auxiliary does is it creates a split for the NFT. So in this case, I'm gonna be taking a split of the smallest deck. So it's gonna be 0.0 10 to the power minus 16 1. So like this is the smallest decimal I have in the system. So that way, decimals this property this asset becomes undividable. It becomes a singular smallest asset. I can define assets of other types that have a supply also associated with them, and I can split up those assets into smaller assets. So yeah, I've successfully, if this auxiliary will create the split and send it to my wallet identities wallet. So that also happened. Now I'm just going to add the assets to my assets and let my carry on. So if this is done successfully, I should be able to see assets in, when I query all my assets, I should be able to see the asset. Yep. So here's the asset. This is the classification ID, as we just mentioned. This is the hash ID. A has value which is represented by this, which is hash string. B has value hash B, C has value hash C, D has value hash D. So not all of these properties are on chain, but some of them are. Let's go ahead and check if these properties are represented by my stored by my maintained by my metas module or not. So yeah, property C and A were meta properties, so I'm able to the meta module is reporting back that it has these metas along with the nub ID that I just defined from my entity. So it looks like my asset is defined well, and all this data is also sorted off. Now, like let's go and check my wallet if it has received the split or the split ownership of this asset or not. So I'm gonna query all instead of I can query a specific one also, but just the team, I think only one should do. So yeah, I can see the identity ID, and this is the ownable ID, which is the asset ID, and I've got the smallest decimal assigned for this particular asset. So yeah, I own the split for this particular asset also. So yeah, good to go. Looks like I successfully assigned and received. Now one might ask, what about, like, yes, I can maintain and I can own splits of NFTs, but what about normal tokens? How can I represent normal tokens as splits? So that's a valid question. What I want your module or your project to be able to represent both of them through a single representation, as in represent an asset or a split of an asset, and a normal token, low-level token, coins in one level. So for that particular scenario, I've got two transactions called wrap and unwrap. So if you send a wrap transaction, whatever coins you send with the transaction will get wrapped and get converted to a SID and added to your identity transaction, and unwrap will do the reverse. So this way you are able to maintain your tokens in your identity wallets rather than your key wallet. So key wallet you might end up losing because you might end up losing the passphrase or the seed of the key wallet. But if you put it in identities, you'll be able to like assign multiple addresses to your identity, and uh, you are able to securely hold your tokens and also be able to exchange them against NFTs. So how do we go for an exchange coins or splits against splits? That we'll get into later on. So yeah, given that I have issued the asset, now the split might keep on going on. It can be carried further into other chains, but there might exist a scenario I might want to modify some of the mutables of my asset. So the issuer of the asset or the person who created the classification gets added to the maintainer set. So this particular address is now also allowed to be able to modify the asset. So let's look at the transaction. How does the mutate asset transaction look like? So we have assets mutate is the name of the transaction, and we have the chain ID minus y to skip confirmation from key name, the key name that you're storing on your local system, the test key, and from ID is the identifier. This ID should be the issuer ID or the maintainer ID of the asset class. So since we utilize our own ID to issue and also own the asset, so our own ID should work. And we have the asset ID as in the exact asset that we want to mutate. Then we have the properties that we want to mutate. So for example, if you had a property earlier that was not a meta property, you can make it meta, but you can only modify mutable properties. You cannot modify mutable properties. If you try to send a transaction with a mutable property specified, you're going to face the issue. So I want to change the property C to E and B string E. So yeah, let's try to do that. Assets, mutate, send transaction. I think at this point, you guys will be well in sync with how the transactions are working. So you might be able to follow the transactions yourself. For the benefit of time, I'm just gonna very quickly go through this. And I just look at the message ones and then I carry on. But the from address, from ID, asset ID, I want to change mutable properties, then immutable properties. So first I go on and verify if the address belongs to the key. Then I create the new asset. Assets already exists. If it does not exist, I say entity not found. If it exists, I carry on. Then I scrub all my keys as in store it in meta if it's a meta, and create a hash meta. I create the mutables. Then I go to conform to check if the properties sent are in conformity with the asset class that I defined. I sent. Then I utilize the maintain auxiliary. The maintain auxiliary takes a set of mutables and changes, modifies the asset in scenario. And then I go ahead and do assets that mutate and create a new asset, the mutated properties. And yes, that's it. Now my asset should have been mutated. Let's go ahead and go to metas and see if a property was ever added to check if our transaction worked. So yeah, we can see that the property E, meta property E has been added here. And let me go ahead and look at my assets. So since now field C and D have the property E, So D and E should end up having the same hashes. So yeah, C and D now have the same property hash because they have the same property, which is E. So mutation successful. Yes. Now let's go to send your NFT. How would you go about sending an NFT? For to sending an NFT, notice that I'm not going to be utilizing this module because the ownership is maintained by the splits or the splits ownership module. So I go to the splits module and create a send transaction with chain ID, from ID, etc. The from ID being my ID. The true ID for this scenario, I'm gonna utilize my own ID so that because I do not have any second ID right now, and then I give my ownable ID and then I give my split value. So let's go quickly and do a split send transaction. Yep. So yeah, the transaction went through. Just to verify transaction went through. This time I'm not gonna be debugging it, but let me transfer this one. So yeah, let's do TX query. So TX query tells me that the transaction was a success. Which implies that if I go right now and query all the splits, since I sent it to myself, I would still see the asset sitting in my wallet being transferred. Yeah, so as expected, this is the split. Now, let's say that you want to take the asset off the chain. It's served its life cycle. In that scenario, I send the burn transaction. Burn transaction can be sent by the issue asset only, and only when the split of the asset is also owned by the issuer. So, for example, if a person A is owning has ownership of the split, then and person B is the issuer, person B cannot go ahead and cannot burn that asset unless it receives back the transaction into its wallet. So the ownership and the issuer should be belonging to the address to be able to send the burn transaction, and then we send the asset ID. So let's go ahead and asset. Yep, looks like the transaction went through successfully. I'm gonna let's track the transaction, how it went on like. So the input, it will look at the message. The message right now has my from address, it has my from ID, it has my asset ID, and this transaction is was gonna create an entity manager is then gonna try to get the asset. It's not nil, so entity own, then it's gonna be checking if the facts are in conformity with my asset, and yep, it's gonna then go to the assets collective and try to burn the asset. So at this point, if I try and query all assets, since I had only one asset in this pool, I am gonna be seeing that there are no assets on this chain anymore. The last asset was burned. And go ahead and check the splits also to see if I still own the fractional ownership of this asset or not. So if I try to do that, I'll see that currently I do not own any splits. So yeah, the ownership and the asset have vanished from my chain now. So there's a burn transaction. Yep. This is the full functionality. This is the end-to-end functionality for a whole flow of NFT. We can enable more functionalities if we import more modules. For example, if I were to import the orders module, so orders module, I can create, I can make transaction, make order. I can make a send a take order, I can query all the orders, I can cancel all the orders, etc. So for example, if I wanted to exchange a split that I have of asset A against 100 of coin B, then I can send a make order, or vice versa. I can send an order to exchange asset A against asset B, or 100 X number of tokens A with with one NFT, or I can have a fraction of NFT to NFT exchange also. So if that is what your application requires, if that is what your use case requires, then you can go ahead and put the mid orders module also. We're not going to get into the order module now. Like that's up to you to explore. All the documentation and the transaction flow remain the same as we have just been exploring. So yeah. Just to like quickly run through, the aim was to create an NFT structure. So yes, we did define an NFT structure, and we issued it to our wallet. We mutated it. We transferred it once, we burned it. So yeah, that's the flow that we followed. Hopefully, this is able to solve the requirement for building your Hack Atom project. If not, then we'll jump into the last section, which is build your own asset module. So we are at like 1.5 hours into the workshop. At this point, if you feel that you have gained all you wanted to gain from this workshop, you have now understood how to import the asset modules and be able to utilize them, and you can choose not to carry further and just continue with that information. But in scenarios, in a scenario that you think that that you want to modify the modules or want to create your own module of sorts, then you may further continue looking at this particular workshop. It's not 100% compulsory, because as I think mostly there would have been a lot of brilliant workshops that would have been conducted since the hackathon started, which will in more detail be discussing how module implementation happens. So for this particular workshop, we're going to add a little twist to it, and are going to be utilizing the persistent SDK types and interfaces to implement our module. Yeah, so let's get started. Just checking if sharing is still on. Yeah, it looks like all is good. Yeah. Build your own assets module. Let's get into this topic. So yeah. Okay. Also, guys, I like for a hackathon, I've already put this workshop online. So if you want more detailed, 1 hour long, like I'm just going to be spending 30 minutes on this. If you want a more detailed and hands-on workshop where I go through the whole module creation process, then there's a video that should go by same name and be from Cosmos India channel. So yeah, starting off. So I'm not gonna be coding for this particular one. I'm just gonna be like guiding you through the proper order of defining a module. So let's pick up a module. Let's pick up the identities module. So the first process will be to define the first thing will be to define the directory structure. So like create a directory with the name of your module. Then we create an internal a package. So anything inside the internal package cannot be exported out. So this reduces the surface of your module, and one is not able to, other modules are not able to touch functionality that they're not supposed to touch. So auxiliaries are the only entities that functionality is exposed by your module that others could import. So we put auxiliaries in the external folder, and then we have the prototype, module prototype. So here we are going to be using a base implementation of the module interface. So the interface looks something like this. It implements app module basic, app module, and app module simulation. So that is why I utilize the module object in my application initialization. One object for all the simulation, app module basic, and app module, because this particular interface implements all three of the other interfaces. And we have the KV store, default param space, get auxiliary, decode module transaction requests. So this is for cause and wasm. And we have the initialize. So when you're starting an application, the initialize method should be called, else you will get panic. So yeah, this is how modules look like. This is how you initialize the module name, default param space, the query route, transaction route, mapper, Genesis prototype, parameter prototype, the auxiliaries, the queries, and the transactions. So what do all of these mean? Let's have a look. Yes, so here my module name is a constant string, which is identities. Default param space is again identities also. My query route is /xprt/identity. So this is basically the route, the REST route, or how would you go about reaching this module service if you were accessing it through URI. So the transaction route, again, the URI path for accessing services offered by this particular module. Then we have the mapper. The mapper object is basically like in Java, you would have a DAO or the data access object. So the data access object has, you can create, again, this is mapper interface schema, and you can utilize a base implementation of the mapper and be able to initialize it through this constructor. The constructor takes in the module name, it takes it the parameter prototype. What are parameters? These are the parameters that we are just discussing, the app params that should be decentralized and that should be governed by governance structure. So these are all the parameters that your module requires. So what would parameters look like? For example, in assets, if I wanted to set the maximum number of fields that an asset could have, so I can set a parameter for it and set it to, let's say, 22 for now. But in future, the web standard changes and the governance wants to change the total number of fields allowed for asset creation to increase beyond 22. So then in that scenario, a governance proposal can be proposed where the number of parameters could be further increased. We have the generate key method. It takes an object of type ID and appends a store key prefix, and generates the bytes of it and generates a KB store key. Then we have identity prototype, as in how would the identity look like, and then we have the register codec, which is the codec. I will get rid of this nuisance when we move 30 version 40. Sorry. So yep. This is how the mapper looks like. Where would the mapper sit? Mapper would sit inside your mapper package, and you can have this the mapper object. You can also define the identifier and the mappable and the collection. So here identity is the mappable. This looks like this. This is the base object that you want to persist. So this is the model. Identity is the collection. This is like the entity manager. So it contains the list. And it does all the aggregation methods like add, remove, delete, etc. So yeah, identity object and entity manager. Create the mapper. Then we go ahead and define the genesis state as when your module is starting from scratch. How would the KB store look like? So here it takes the codec, it takes all the mappables, as in all the identities that should be initialized in the beginning. So right now it's empty, and all the that should be initialized from the beginning. So it takes the parameters prototypes default parameter list. So that's how we create the Genesis. The Genesis object is again a base implementation which exposes methods like default Genesis, validate, import, export, marshal, and initialize Genesis state. Then we have the parameters. For identities module, we do not have any parameters. We have defined dummy parameter. The dummy parameter just is an ID whose default value is default data is the smallest deck, and and this is the validator method which validates if your within the defined parameter limits. So yes, this is the parameter object which creates a parameter taking in a valid set of all the parameters for your module. So it can take as many parameters as you want to send it. So this is a parameters object. Parameters object you pass to mapper, and mapper is then able to utilize all the parameters. So then we have queries. Queries. This is a collection queries. We have query entity. So we have the request object. Again, this is interface defined by the SDK. And you have the response objects. You have the query object. Query object takes in the name query URI path to the query. The long description of the query usage and the short description of the query usage, packet codec, registration of the packet codec, initialize query keeper, the method that initializes the query keeper, the request prototype, response prototype, and flags. So flags are the CLI flags that needs to be labeled for this CLI command. A keeper is the main logic. So here it's very simple. It goes to the mapper and fetches the object and then just sends it back, easy as that. So the constants create all the name of the query and all the constant strings. Register correct, registers the correct. Transactions very similar to queries, same structure. We have the request, we have the response, we have the message which gets sent to the keeper. We have the keeper logic, we have the constants, and we have the codec, and we have the transaction object taking the module name, transaction name, URI route, description, log description, register codec method, initialize transaction keeper method, and the request prototype method with all the flags that needs to be labeled for this CLI command. The transactions object is the collection of all transactions. Again, it takes a valid set of all the transactions for your module. You can take transaction as you like. So yes, Genesis, mapper, parameters, queries, and transactions. You need to define these. On top, you need to find auxiliaries. Auxiliaries are a set of methodologies or methods that need to be exposed by the module to external modules. So how does it look like? You have the auxiliaries collection, which takes a valid set of auxiliaries defined in the project. It again is very similar to how queries and transaction look like. We have the request, which adheres to auxiliary request interface, which again extends the request interface, which has validate method. Similarly, we have the response object, which adheres to auxiliary response interface, which extends response-based response interface. Then we have the keeper. Keeper has the core logic for this auxiliary. Constants have all the strings, and auxiliary object defines the auxiliary object. auxiliary looks like this. It has the module name, it has auxiliary name out, and the method to initialize the keeper. So yeah, that's how auxiliaries look like. Now we have defined auxiliaries, the genesis, mapper, parameters, queries, and transactions. So all of these together, put together, create one module. So let's go ahead and create our module object. So the module object again is an interface that we define, which implements other interfaces also that are required for the application, like simulation manager, app module manager, module manager. So how do you create a new object, a new module object? You take the module name, you take the param space, the query route, transaction route, or the URI addresses to the query and transactions. Take the mapper prototype, the genesis prototype, the parameters prototype that we just defined. Yeah, so this is the parameters collection, the parameters prototype. And auxiliaries collection, queries collection, transaction collection. Even all of these, this particular module is going to generate all the boilerplate code. So boilerplate code like initialization, decode request, get auxiliary, get KB store. All of these are simple. Let's go to something more. So it will create a query command, a CLI command for you. It is going to create a transaction command for you with all the transactions initialized. It's going to create, it's going to register all the loads. It's going to register the codec. And yes, so all the boilerplate code. So that's how you create a module end to end. And yeah, how does one access external auxiliaries from one module to the? So let's go to the assets module and see how it's consuming identities auxiliary. So let's go to mint transaction and we go to the keeper. We see that there is an initialization function for the transaction keeper. It takes a Veradex set of auxiliary. Not a Veradex set here. It's an array of auxiliaries, which are external keepers. So these auxiliaries go through a case match where I match the name of the auxiliary to the task auxiliary name. And if it matches, then for my keeper structure, I can set the external auxiliary and like have a object with a keeper initialized with the external auxiliary. So in this scenario, my identities module exposes an auxiliary called verify, which does verification of key against an ID. So yeah, here I've got a verify auxiliary. The verify auxiliary transaction keepers structures verify auxiliary has a method called get keeper. So this gives me an auxiliary keeper. Auxiliary keeper has got a method exposed called help. So this is so basically this module is helping identities module here is helping the asset module. So how does it help? It takes the context, it takes the request, auxiliary's request. The request has a from and ID. So this particular auxiliary then tries to check if the identifier has the from address as one of the provision addresses or not. If not, it's going to return an error and it's going to say it's not successful. It's going to return a non-successful. The response is going to be non-successful. And if it's so, you can return back a new transaction response with the auxiliary responses and get there. So this is how you utilize external auxiliaries inside your transactions. And yes, that's it. That's how you define a module. So let's go through the list. We define a directory structure. We define the mappable, which was the identity.go object. We define identity ID.go. We define identities with the collection. We define the parameters which are dummy in it. Right now, we define the constants. Yes, we define the codec. We define the mapper prototype, the entity manager as we call it. Define the genesis state which had no mappables and the list of default parameters set. Then we define the module through defining the auxiliaries, transactions, queries, and module prototype. Create application. So yeah, let's go and create the application. So by default in Schema, I've created one base implementation of the application. So this is the most basic application that you can create that will have a Cosmos SDK modules and all the persistent SDK module. So it looks the object looks like this, and the interface is something like this. Interface extends the application interface extends the Tendermint API application interface, and on top adds two more methods: load, hide, and export application genesis state and validator. So yeah, this is how the application looks like. This particular method, the this load height method, a particular it loads the state, and the prototype method basically creates one simple prototype of the application, and return backs a new application method. So you can utilize new application method inside your main.go of your real application and run the application from there, as long as you're providing the initialized logger, DB, trace store, load store, checks, invalid period check, the height of the upgrade height, the home directory path, and base app option for the base app. So yes, this is how the basic application implementation look like. You can either choose to directly import and utilize this, or you can go ahead and write your own application.go. Let's see how this particular base application has been utilized in Asset Mantle. So in the Asset Mantle project, I have gone ahead and called the base.prototype method. So I've defined name of my application, which in this case is called Asset Mantle. You can define your own. The codec I've made through initializing and registering codec for all the packages that have their own codecs, and then passing all the other options like module account permissions, token modules that are allowed to receive the tokens, and enable all proposals for WASM method. So uh, this particular object gives back all the modules that was enable. So yeah, this is my app module basic. It basically contains all the objects, app module basic objects, and yeah, these are the module account permissions, which module has access to what module, and allow tokens, allow module that can receive tokens. So yeah. That's how I define the application. Initialize the package here in Asset Mantle. Have all the utilities. Utility command that one might require to set up an application. And yes, that's how my application look like. Client, where the client has CLI and REST. So yeah, need to initialize also. And the node has my main node or the real blockchain. So initialize like so. No innovation here. Just need to copy paste code as is, except for if you need to add special extra commands, external commands that are not represented by any module. That's not really have to modify this particular method also. And then we have the contracts. The contracts here contain a basic smart contract that you can utilize with the assets module. So it basically gives you custom logic for defining a smart contract using COSM WASM. Other than that, these are some of the helper directories. So JMeter has the JMeter test plan with all the transactions in sequence to do performance testing. The .rest has all the .rest endpoints, and you can directly, if you have Golang, then you can directly utilize to run from Golang itself. .run has .run configurations, so you can utilize .run configuration to run uh, and debug run configurations. Scripts have, as I was showing, the startup, the setup script, which sets up the Genesis startup just now. On top, we have the transactions script. So this basically does a run of all the transactions. It runs all the transactions in sequence, and Wasm contract ethics sets up the Wasm contract environment. So, yep, that's it. We have already run the application, done the node, done the discussion, defining transaction logic. Yep. Using other modules, define the transactions over IBC. So yes, to discuss this, for your module to be able to send transactions over IBC, you can define a custom layer that is permission that keeps on iterating your KV store, and based on certain trigger events, it creates and sends a transaction to other chain. But that would be a centralized and approach for the layer. It would be like a centrally permission bridge rather than uh, inter, rather than interoperability at the native level. So if you want native interoperability between chains, the IBC protocol is now ready. It comes with the release 0.4.0. So if you want to build multiple chains that interact with each other through a decentralized medium, then you have to utilize version 0.40 of your SDK to build your application. Else you can continue utilizing 39.0. Why would you want to build on 39.0? Because it's a LTS version and will be supported for a good amount of time, and it's the most stable version, also a production version at this point. So, yep. To discuss, there are other tools that you might require that you can. For example, if you wanted an Oracle network, you can utilize Oracle network. So that's Cosmos based. You can send and receive transactions and data set and their verifications also through IBC. Band chain, it has recently entered mainnet, if I'm not wrong. For AMM, IXO Foundation has created a module called Cosmic Bonding, which is available at this GitHub link. So this basically your basic automatic market maker bond curve that you define. For stable coins, we have the Terra project, which does a variety of stable coins like Korean won and USD. And for EVM smarts, if you want to run EVM smart contracts on your chain directly from that you might create Ethereum and use the Ethermint, so that this will save you a lot of development time. You can directly utilize your own old Ethereum smart contract to run to build your project. And finally, if you create a Wasm contract, then we have the Cosm Wasm module. So as I was just discussing, all the persistent SDK module are by default with an integration with the Cosm Wasm module. If you do Wasm module, then you can import and the Cosm Wasm module also, and be able to on runtime upload Wasm bytecodes to your chain and change the way your put custom logic for your module and change the behavior of a chain on run. So yeah, I think that's it. We went through a lot of it, and yeah, looks like we've mostly covered all of it. And yeah, and we went at a very rapid pace through all of these modules and all of the developed code bases, etc. And there is a lot more complexity to building products than that we just discussed. So if you do trouble, if you do run into issues, like feel free to get in touch with the person team. We are running office hours over 2 days, and you can directly get in touch with the team and get your issues or queries resolved. So yes, be sure to like say come and say hi if you have any issues running all of these modules. We'd love to hear from you guys. So yeah, I guess that's it. Thank you guys for joining into this workshop. Hope you found it productive, and hope that you build something very interesting in this hack atom. So best of luck with hack atom right now. Thank you guys.